Thermal voltage. Thermodynamics is a very important subject in civil and mechanical engineering. However, the topic which we are going to discuss here is very basic, which you might have already studied in earlier classes. We know kinetic energy of gases is equal to kT, where T is temperature in Kelvin and K is Boltzmann constant, whose value is equal to 1.38 into 10 raised to the power minus 23 joule per Kelvin, or 8.617 into 10 raised to the power minus 5 electron volt per Kelvin. This particular equation of kinetic energy is the place where the Boltzmann constant originated, and in study of semiconductors also it plays significant role. For semiconductors, we know that an electron in the valence band requires energy for making its transition to conduction band. This energy can either be supplied by vibrational energy, which is nothing but thermal energy which increases as temperature increases. Another way of supplying energy is by connecting the semiconductor by an external battery with very high voltage, supplying electrostatic energy to the electrons in the semiconductor. The concept of thermal energy tries to establish a relation between the two different forms of energy we just discussed, namely electrostatic energy and vibrational energy. The term thermal voltage is used because it relates the change in voltage that occur due to temperature variations. As the temperature of the semiconductor increases, the thermal energy of the charge carriers within the semiconductor also increases. This increase in thermal energy makes electron transition easier. Thermal voltage is usually represented by Vt. Now, if we equate the two different forms of energy, then we will get volt equivalent of temperature. It can be observed that thermal voltage is directly proportional to temperature. We know Boltzmann constant and charge on an electron both are constant parameters, and after applying the numerical value of both these parameters, we will get thermal voltage equal to temperature in Kelvin divided by 11600 volts. At room temperature, when T is 300 Kelvin, approximate value of thermal voltage is 26 millivolt. For this particular subject of electronics engineering, you should always remember that the temperature is very crucial parameter on which almost every concept is dependent. For numerical problems also, do check carefully what temperature is provided and at what temperature the value of other parameters are provided. Another small topic is different temperature scales like Fahrenheit, degree Celsius and Kelvin. There are formulas through which you can easily convert temperature from one scale to another. For example, temperature in Kelvin is equal to temperature in degree Celsius plus 273. Similarly, temperature in Fahrenheit is equal to 9 upon 5 temperature in degree Celsius plus 32. By using these two formulas, one can convert temperature in one scale to another scale easily.